The list is entitled Integration of Mass Position Monitoring and Auto Centering on Indonesian Seismic Networks.
Good afternoon, everyone. Let me introduce myself. My name is Amir. I work for the Agency for Meteorology, Climatology, and Geophysics of Indonesia. And at this time, I would like to talk about the integration of mass position monitoring and centering on Indonesian seismic stations. So this is the outline I will talk about. The first would be the challenge in Indonesian seismic network maintenance, the system integration as an alternative solution, and lastly, the proposed advantage and challenges of the system. Okay, the first one, the challenge in Indonesian seismic network maintenance. It covers the first challenge, the fragmentations. We do have about 5 or 6 instruments from different manufacturers, and they share nothing in common. So they all have their own application and their standards. Those differences create an inconsistent monitoring, such as one brand, they do scale the mass position by their voltage. So -4 to 4 voltage, while the other put a scale on 1 to 10. So that's one of the differences. The second challenge is the geographic scales. Indonesia operates about 552 stations throughout the Indonesian islands. So it's a lot of stations to monitor by a single person or just one organization without a unified dashboard or interface. Now those add up to one of the core issues is the compromised sensor mass position, how we would be troubled with this phenomena when we are not be able to monitor mass position regularly and their overall health regularly. So the proposed solution is a system integration as an alternative solution to give those sensors from different manufacturers a unified and scalable web interface to monitor and take actions. We propose a web-based dashboard because most of the manufacturers, besides their own applications, they also provide a web interface or graphical user interface. And we use HTTP to post and get data from those digitizers. The unified dashboard is a web-based platform that brings together data. Mainly, as of right now, it's the mass position. And we could see their name, the digitizer name, their station, their mass centering counts, and the state of health. We simplify with colors to make monitoring easier. The second part of the system is the controller. The integrated controller consists of one, the check digitizer. It eliminates one step in monitoring. Prior to this system, the monitoring consists of us taking the visuals from every sensors, 500 of them, and we check manually by clicking their respective IP addresses. This web is tackling those problems by listing them in a one page, so we just click them and could check them. It also have the center mask option. It will be a HTTPS post, so the web posts to the digitizer to center the mask should it be needed. And lastly, it also have the auto center, and this will be the core of this web to unify all digitizers how to auto center them not through the web interface, but not through the digitizer, each one of them, but through a web interface, significantly saving valuable time and resources. So lastly, the proposed advantage and challenge. These web interfaces would be proposing enhanced operational efficiency, implementing centralization and automation streamline process. The second will be the focus on the data. A corrupted mass position would be critical for the seismic data. It would cause clipping. Now, when the earthquake or the surge in earth movement gets so big and the mass is not on the center, it would clip, and it's not good data. The third thing is minimize downtime. A corrupted sensors is unusable. We use 3 components, the vertical, horizontal, and 2 horizontals. But when the mesh is corrupted, especially the vertical component, it's unusable. So by monitoring the mesh, we could see how's their behavior. Typically, when sensor is nearing the failure, they would center the mesh frequently every day. Could be 10 times, 100 times, or whatsoever. They are failing their own mass position management. And with this web integration, we could monitor their centering counts and possibly turning them off or tell the staff to look after them before they get failed. The last advantage would be scalable blueprint, because HTTPS and web interface is giving us an opportunity to scale our monitoring system. Unlike the manufacturer's interface, you could not put them together because obviously there are different brands and not possibly could be put into one together. So the web is offering those advantages. Now, lastly, we also have challenges because the backbone of this web-based interface is HTTP. Most of our digitizer does not support HTTPS with their encryption, so we should have a better protocol, or maybe we could use VPN or something to encrypt the data to prevent infiltration and other cyber threats. Okay, that's it from me. Thank you for your attention.
Thank you for giving us the insight into your huge network. Are there any questions?
Thank you. As you said, you have 552 seismic stations all around Indonesia. You are proposing this integration among those 552, or these 552 includes that CTBT also?
That would be including the CTPTO.
So as you said, these are different protocols they are using, different parameters they are using, or the numbers they are using. Do you have to rewrite everything to integrate all these different stations or different networks parameters into one? You have to rewrite everything, or just on this web-based, the model you are proposing?
Okay, thank you for the question. We look back at the digitizers, their scale, actually. If we're talking about mass, that would be the how their mass is further the distance between 0 and their mass position. So every digitizers and sensors have their own scale. But generally, the scale is the same. It's measuring voltage. Most of them are plus minus 4 voltage, so we could transfer them into my proposed web base would be the scale from 1 to 10, minus 10 to plus 10. So if one of them using minus 4 and 2 plus 4, it just be calculated from to minus 10 to plus 10. That would be in general.
Thank you. No more questions? Thank you so much. Very interesting.
Thank you.